Hi, Year 11. I just wanted to clarify the situation with maths mock exams. I know you got a message from Mr. Tilley at the end of last week. We hope we're going to be back in school at some point soon. And as Mr. Tilley said, we'll be doing mock exams shortly after that. And the mock that we will do in maths will be the one we were planning to do at the end of January. So the revision list that we gave you at the end of the autumn term is the revision list that you need to be working on. And over these next few weeks, your teachers will be doing some video revision lessons, as well as finishing the syllabus, both of which are very, very important. But I urge you to carry on in your own personal time, revising the topics on that list and getting in touch with your teachers if you have any concerns about any of those topics. Take care. So we have definitely moved away from standard form now. Been really impressed with the quality of work many of you produced so far, which is great to see. You are doing, as I said in the last video, exactly the right thing. Now, what we're doing for the next 6 lessons is something that all of the groups are doing. You will remember, hopefully, being given this revision list. I'm going to attach it again to today's lesson, but I'm hoping it's not new to you. But these are a list of topics which feature in the mock exam. And what we did as a maths department, we agreed that we would teach 6 revision lessons on specific topics. And we'd also do 6 lesson starters. So we're going to do the 6 lessons over the next 6 lessons, and then we'll do some starters later on in this half term. But you've also got topics which we're not going to cover together, and so we're hoping that you will cover yourselves. And you've got pages in the revision guide that we gave you at the beginning of the year, and also some Maths Watch videos to look at. So we're going to start that process, and I'm going to start today with this one here. I'm really clear with the team of maths teachers that everyone needs to get the same amount of support. I don't want one group getting more support than others. That's why we've agreed these topics are the ones we're going to go through. So we're going to talk about sequences, and in particular a sort of sequence called a linear sequence. So this is our objective, the nth term of a linear sequence. It's an odd objective. You may have no clue what that means. It might be something that rings a bell. It might be something that you've already revised, in which case you're going to find this lesson really, really easy. So let's start by having a look at 4 number sequences. And I'd like you to tell me what's going on in all of them. And could you tell me the next term in each sequence? Hopefully you were able to see that this sequence, we were just adding 3 each time. So the next sequence, the next number in the sequence would be 16. In this sequence here, we were multiplying by 4 each time. So that would be that. This was a bit trickier. 2 ways you could have looked at this. You might have recognised these as the square numbers: 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. So the next one would be 6 times 6. Or you might have looked at the gaps and realised that that's got a gap of 3, and this has got a gap of 5, and this has got a gap of 7, and this has got a gap of 9. So those gaps are getting bigger. So the next gap would be 11. And this is a weird one. With this one, if you take the first 2 numbers, the next number are those 2 added together. So 5 is 1 plus 4. And then 9 is 4 plus 5. And 14 is 5 plus 9. So the next term would be 9 plus 14. So that's 23. And you may remember those sequences are referred to as Fibonacci sequences, named after an Italian mathematician. But sequences where to get the next term you add previous terms together. They're called Fibonacci. Now today is all about this sort of sequence here. Okay, this sort of sequence here, the gap is always the same. In this case, it's 3. And these sorts of sequences are referred to as linear sequences. If I was to get a graph and plot these values, so along the bottom I had which term it was, and I was plotting these values up the side, because the jumps are the same, I'd get a straight line, and that's why they're called linear sequences. So our objective for today is about taking linear sequences and describing them using formulas. So it's the formula for the nth term of a linear sequence. Now, if I had my way, we'd never refer to the nth term. I think it's a confusing, unnecessarily confusing phrase, but it crops up in exams, so we have to do it really. Now, this is something you've done before. We're revising this, sorry, I should say, it is very likely, therefore, that I'm going to explain it a little bit differently to the way teachers have explained to you in the past. I'm very relaxed about that, because I think the more ways you've got of doing something, the better placed you are. So hopefully you're going to be able to remember the way that we do it, and if my way is a new way, maybe it's something that you'll find a little bit easier. Let me start with a linear sequence. Okay, I can tell this is a linear sequence because the gaps are going to be the same. We talk about terms in a sequence. The word terms, this is the first term, this is the second term, this is the third term, this is the fourth term, this is the fifth term. So we talk about those terms: first term, second term, third term, fourth term, fifth term, and we refer to the term number with the letter n. You can perhaps already begin to see where the nth term is coming from. So I'm going to turn this into a little table. Now, hopefully you can see that this sequence here, you are adding 5 each time. And, you know, that's easy to predict the next term in the sequence, but that's not what we're trying to do. We're trying to write a formula that describes this sequence. Well, let me write another sequence where you add 5 each time. That's the 5 times table. To get these numbers, you just do 5 times their position in the sequence. So the third number in the sequence is 5 times 3. So we say the formula for that sequence is 5n. Would you like to suggest what the formula for this sequence is, therefore? I'm hoping you can see that this sequence, each term is 1 smaller than this sequence. So we say the formula for this is 5n minus 1. And it's really easy to do that process as long as you can quickly recognise that the fact you've got a gap of 5 means that it's something to do with the 5 times table. Let me write you another sequence out. Okay, here's another sequence. Okay. So this sequence, hopefully you can see we are adding 6. So I know it's something to do with the 6 times table. I'm going to write the 6 times table above my sequence. The formula for the 6 times table would be 6n. To get any of these numbers, I just do 6 times their term number. Can you therefore see what the formula for this sequence is? It's going to be 6n plus 2. Easy peasy. Easy peasy. Okay, let me give you another example. Can you see if you can tell me the formula for that sequence, please? Pause and then I'll show you. Well done if you got 4n minus 2. So I spotted the gap was 4, something to do with the 4 times table. My sequence is 2 smaller than that. So it's 4n minus 2. Okay, 3 more to try. There's something different about this last one, so I'm hoping these two you'll be able to do. They're similar to that. Something different about that one. Have a go. Pause and have a go. Right, so this sequence going up in tens, so it's something to do with the 10 times table. 10 times table's got the sequence formula 10n. My sequence is 4 smaller than that, so it's 10n minus 4. This sequence going up in threes, so it's something to do with the 3 times table. 3n. Bit fiddly maybe. My sequence, if you're not very good with negative numbers, have a look up here. It's 7 smaller, isn't it, than that? So 3n minus 7. Okay, so this sequence here, going down by 4, and it's important you recognise that. So this sequence is something to do, not with the 4 times table, because the 4 times table gets bigger as it goes through. Here it is, the 4 times table. This is something to do with the minus 4 times table. Now, those of you that learnt your times tables at primary school, you didn't learn the minus 4 times table, but I've got good news for you. It's the same as the 4 times table with a minus sign in front of it. So and the formula for the minus 4 times table is minus 4n. How do I get from the minus 4 times table to my sequence? Well, my sequence is definitely bigger. It's 9 bigger. So the formula for my sequence is minus 4n plus 9. And sometimes you see people say, I don't really like having the minus at the front there. So they rewrite that as 9 minus 4n. It means the same thing. It means the same thing. Okay, can I give you one more, one like that that's going down? Let's have a go at this one. See if you can have a go at that one there. Pause and come back. Okay, so this one is going down 6 each time. So it's something to do with the minus 6 times table. Don't teach that at primary school, but it's nice and easy. It's just the 6 times table with a minus sign in front of it. Its formula is minus 6n. This is the fiddly bit, isn't it? This is clearly bigger, but how much bigger? From minus 6 to 11, well, that's a jump of 17. So it's minus 6n plus 17, which some people write as 17 minus 6n. Now we might be asked to work in reverse. They might give us the formula for the sequence and ask us to generate the sequence. It might say, write down the first 5 terms of the sequence with the formula 8n minus 5. So here's how I would do it. I'd say, okay, I know this formula, this sequence is something to do with the 8 times table. So I'm going to start by writing out the 8 times table. 1 8, 2 8, 3 8s, 4 8s, 5 8s. I'm doing 1 2 3 4 5. I could go on forever. I don't want to go on forever, so I'm stopping at 5 terms. So my sequence is 5 smaller than that. So all I've got to do is take away 5 each time. So 8 take away 5, 16 take away 5, 24 take away 5, 32 take away 5, and 40 take away 5. That gives me my sequence. Okay, pause and have a go at that one. And then when I come back and go through the answer to that, I'll also talk about how we would do the third one. Okay, so this sequence, something to do with the 3 times table. So I've written out my 3 times table. 8 bigger than the 3 times table. So I've just got to add 8 to each of those numbers. 16 plus 8, 6 plus 8 is 14. 9 plus 8, 17. And once you've written your sequence out, you can check whether you got it right. This sequence should have a gap of 3. And if any sequence with a 3n in the rule is going to have a gap of 3. So let's just check. Yeah, add 3, add 3, add 3, add 3. Bingo. This one here, I'm going to rewrite it first as minus 2n plus 10. So I know it's something to do with the minus 2 times table, which is the 2 times table with a minus sign in front of it. So all I've got to do is add 10 to those numbers. So minus 2 plus 10, minus 4 plus 10. And at that point I can say, well, okay, I know this sequence is going to have a gap of minus 2. So it's just going to be going down 2 each time. So I've got a couple of ways of working it out. I can either take away 10 from each of those numbers, add 10 to each of those numbers, because it's 2n, minus 2n plus 10, or I can say I know the gap's going to be minus 2. Right, let's look at a couple of exam questions then. So here are 3 exam questions. One thing I should have made, and it would be very good to add to your notes, is these sequences, I've been calling them linear sequences. They are also referred to as arithmetic sequences. They involve arithmetic, you're adding the same thing each time. So arithmetic sequence, linear sequence, they mean the same thing. They are a sequence where the gap is always the same. So here are 3 questions I'd like you to have a go at and submit. Very, very straightforward. You just got to tell me what the formula is for each of these sequences. As usual, they make it sound more complicated than it is by talking about this in terms of n, the nth term. They just want the formula, just what we've been doing in the video. Have a go at these 3 and submit it on class charts, and then we'll move on and do a bit more linear sequence work next lesson. Can I finish by apologising for my doofus mistake in Friday's video? This was a division sum, and I said 9 divided by 2 was 1.8. Obviously it's not. 9 divided by 2 is 4.5, and then because you're dividing, you subtract the indices, so you get 10 to the power of 3. So it was 4.5 times 10 to the power of 3, and I'm very grateful to those of you who pointed out my mistake. Well done for doing that. Please do that at all times.